Question number 21. How do you ensure the efficient operation of combustion systems in an HFO power plant? Answer. Efficient combustion is ensured by optimizing fuel-air ratio, maintaining proper burner settings, monitoring combustion parameters such as oxygen levels and flue gas temperatures, and conducting regular inspections and tuning of combustion equipment. Question number 22. What role does instrumentation and control systems play in monitoring and controlling machinery in an HFO power plant? Answer. Instrumentation and control systems monitor parameters such as temperature, pressure, flow rates, and vibration levels, providing real-time data for operators to make adjustments and ensure optimal performance and safety of machinery in the power plant. Question number 23. How do you mitigate the risk of boiler tube failures in an HFO power plant? Answer. Mitigating the risk of boiler tube failures involves implementing water treatment programs to control corrosion and scale formation, conducting regular inspections and non-destructive testing of boiler tubes, and implementing proper operating practices to prevent overheating and fatigue failures. Question number 24. Can you discuss the importance of proper lubrication practices for rotating equipment in an HFO power plant? Answer. Proper lubrication ensures smooth operation, reduces friction and wear, dissipates heat, and extends the lifespan of bearings and gears in rotating equipment. It involves selecting the right lubricant, establishing lubrication schedules, and monitoring oil quality and levels. Question number 25. How do you handle emergency shutdown procedures for machinery in an HFO power plant? Answer. Emergency shutdown procedures involve activating safety systems such as emergency stop buttons, initiating emergency shutdown sequences for critical equipment, isolating power sources, and evacuating personnel to ensure their safety during emergencies. Question number 26. What steps do you take to prevent steam turbine blade erosion in an HFO power plant? Answer. Preventing steam turbine blade erosion involves controlling steam quality and purity, implementing proper water treatment to minimize impurities, and maintaining proper blade clearance and steam flow conditions to prevent erosion and erosion corrosion. Question number 27. How do you ensure proper insulation of steam and condensate piping systems in an HFO power plant? Answer. Proper insulation of piping systems involves selecting appropriate insulation materials, ensuring proper installation techniques to minimize heat loss or gain, and conducting regular inspections to detect and repair any damaged insulation. Question number 28. Can you explain the function of condensers in the steam cycle of an HFO power plant? Answer. Condensers condense exhaust steam from turbines back into water by transferring heat to cooling water, allowing it to be recycled back into the boiler. This process increases the efficiency of the power plant by maximizing the use of steam. Question number 29. How do you address issues related to water hammer and steam piping systems of an HFO power plant? Answer. Addressing water hammer involves installing proper piping supports and expansion joints, controlling flow velocities to prevent sudden pressure surges, and implementing water hammer arresters or dampeners to absorb shock waves. Question number 30. What measures can be taken to optimize the performance of air compressors in an HFO power plant? Answer. Measures to optimize air compressor performance include regular maintenance such as cleaning filters and lubricating moving parts, monitoring and adjusting operating parameters such as pressure and flow rates, and implementing energy-saving technologies like variable speed drives. Question number 31. How do you ensure the proper functioning of feed water pumps in an HFO power plant? Answer. Proper functioning of feed water pumps is ensured by regular inspection and maintenance, including checking for leaks, monitoring pump performance parameters such as flow rate and pressure, and ensuring proper alignment and lubrication. Question number 32. Can you discuss the importance of proper steam turbine gland sealing in an HFO power plant? Answer. Proper gland sealing prevents steam leakage from the turbine casing, which can result in energy losses and reduce turbine efficiency. It involves maintaining tight seals, monitoring seal performance, and addressing any leaks promptly to minimize steam losses. Question number 33. How do you optimize the performance of economizers in a boiler system of an HFO power plant? Answer. Optimizing economizer performance involves cleaning the economizer surfaces to remove soot and ash deposits, ensuring proper water treatment to prevent corrosion and scale formation, and adjusting the flue gas temperature to maximize heat recovery efficiency. Question number 34. What measures can be taken to prevent fouling and scaling in heat exchangers of an HFO power plant? Answer. Preventive measures against fouling and scaling include implementing proper water treatment programs, using chemical inhibitors to control scale formation, conducting regular cleaning and descaling procedures, and optimizing flow rates to minimize deposition. Question number 35. How do you troubleshoot issues related to boiler feed water quality in an HFO power plant? Answer. Troubleshooting feed water quality issues involves testing water samples for impurities such as dissolved solids, oxygen, and alkalinity, identifying the source of contamination, adjusting water treatment chemicals and processes, and monitoring water quality parameters regularly. Question number 36. Can you discuss the role of steam traps in condensate recovery systems of an HFO power plant? Answer. Steam traps are essential components in condensate recovery systems as they remove condensate from steam lines and equipment efficiently. Properly functioning steam traps prevent steam wastage and ensure the return of high-quality condensate to the boiler feed water system. Question number 37. How do you ensure the reliability of boiler safety valves in an HFO power plant? Answer. Ensuring the reliability of boiler safety valves involves regular testing and maintenance, including bench testing, adjusting set pressures, and replacing worn or damaged components as per manufacturer recommendations. Question number 38. What role do deaerators play in the steam cycle of an HFO power plant, and how do you maintain their efficiency? Answer. Deaerators remove dissolved gases such as oxygen and carbon dioxide from boiler feed water to prevent corrosion and improve heat transfer efficiency. Maintaining their efficiency involves monitoring and adjusting operating parameters, regular inspections, and proper maintenance of internal components. Question number 39. How do you prevent water hammer and steam turbine condensate lines of an HFO power plant? Answer. Preventing water hammer involves installing proper drainage and venting systems, ensuring adequate steam trap operation, controlling condensate flow rates, and implementing measures to minimize sudden pressure changes in the piping system. Question number 40. Can you discuss the importance of blade profile maintenance in steam turbines of an HFO power plant? Answer. Maintaining the proper blade profile in steam turbines is crucial for efficient energy conversion and preventing aerodynamic losses. Regular inspection and maintenance of blade profiles ensure optimal turbine performance and minimize energy losses. Question number 41. How do you ensure the reliability of diesel engines used as backup power sources in an HFO power plant? Answer. Reliability of diesel engines is ensured through regular maintenance, including oil and filter changes, fuel system checks, cooling system inspections, and testing of starting and shutdown procedures. Additionally, conducting periodic load tests helps ensure the readiness of diesel generators during emergencies. Question number 42. What measures can be taken to minimize vibration in rotating equipment such as turbines and generators? Answer. Minimizing vibration involves proper installation with adequate foundation support, alignment checks, balancing of rotating parts, routine vibration monitoring, and timely corrective maintenance to address any issues detected. Question number 43. Can you discuss the importance of proper lubricant storage and handling in an HFO power plant? Answer. Proper lubricant storage and handling are crucial for maintaining lubricant quality and prolonging equipment lifespan. This includes storing lubricants in clean, sealed containers, implementing a first-in first-out inventory system, and ensuring proper labeling to prevent cross-contamination. Question number 44. How do you conduct failure analysis for mechanical components in an HFO power plant? Answer. Failure analysis involves collecting data such as operating conditions, maintenance history, and inspection results, followed by visual inspections, non-destructive testing, and root cause analysis to determine the factors contributing to the failure and implement corrective actions to prevent recurrence. Question number 45. What are the key considerations for selecting materials for construction and repair of equipment in an HFO power plant? Answer. Key considerations include compatibility with operating conditions, temperature, pressure, corrosive environment, mechanical properties, strength, toughness, availability, cost-effectiveness, and compliance with industry standards and regulations. Question number 46. How do you ensure proper functioning of hydraulic systems in an HFO power plant? Answer. Proper functioning of hydraulic systems is ensured by maintaining proper fluid levels and cleanliness, inspecting hoses and fittings for leaks or damage, monitoring pressure and flow rates, and conducting regular maintenance of pumps, valves, and actuators. Question number 47. Can you discuss the significance of rotor dynamics analysis in optimizing the performance of rotating machinery in an HFO power plant? Answer. Rotor dynamics analysis helps predict and mitigate issues such as unbalanced forces, critical speeds, and resonance that can lead to vibration, premature wear, and failure of rotating machinery. By optimizing rotor dynamics, the reliability and efficiency of equipment can be improved. Question number 48. How do you prevent overheating in electrical components such as motors and transformers in an HFO power plant? Answer. Preventing overheating involves proper sizing and ventilation of electrical enclosures, monitoring operating temperatures, ensuring adequate cooling airflow, and performing routine inspections and maintenance of electrical components. Question number 49. What role do expansion joints play in the piping systems of an HFO power plant, and how do you maintain their integrity? Answer. Expansion joints accommodate thermal expansion and contraction of piping systems, preventing stress and damage to connected equipment. Maintenance involves visual inspections for signs of wear or leakage, replacing damaged components, and ensuring proper installation to accommodate movement. Question number 50. How do you optimize the performance of cooling towers in an HFO power plant? Answer. Optimizing cooling tower performance involves monitoring water flow rates, adjusting fan speeds to maintain proper airflow, controlling water chemistry to prevent scale and corrosion, and implementing water-saving measures such as drift eliminators and basin covers. Regular cleaning and maintenance also help ensure efficient heat exchange.
Hope this video is helpful for my subscribers. Stay in touch with our channel. Wait for our next video tutorial. Till then, bye bye.